Who jumps out of perfectly good airplanes in the name of science? Mr. C.
Happy downhill day. It's all downhill after today on this Wednesday. Number of reminders for you. Then I've got some neat data to show you that I think you're going to find quite interesting. You better. Anyway, you'll be glad you came to science today, I think. So you 7th graders. And I've got 2 boxes of rocks down here to pull out a bunch of stuff. So while I'm getting all my things together and reviewing, if you would take out this, if you'd get a highlighter out, a pen, and if you'd turn to LS2, Lesson Summary 2. Okay. Any of you are LO students? Quite a bit later in the day, but this will be up. So, I'm sorry, I don't have it up for you right now, but I will. And future lesson summaries. We're going to go over Lesson Summary 2, the properties of minerals. So we're going to go over it. And we're going to go over this. We'll use this. Our more about rocks and minerals paper. We'll go over it. And I think we did so far, I think maybe we've done 1 or 2 so far, I think, minerals from that sheet. So, hey, just a few reminders before I show you some really cool things. Makeups, if you've still got a makeup, test 1 or 2 from this quarter. You've got to get those done. Our LO students, you've got to post those to me if you haven't. Test 1 and test 2 of quarter number 4. Our last quarter. Woohoo! Last quarter! So, if you'd also have out your journal, just in case you need to put anything in it, remember I'm going to do a big fat journal check right at the end of the year in about 6 weeks. It's going to be a lot of points. Right now I'm aiming at about 30, so it's going to be like a small test size, but it could make or break you. If you have not been filling your journal in and you don't really care, you might want to start caring. And you might want to borrow somebody's and get caught up. You might want to think about, now let me see now, who is possibly a really good student who would have kept really good notes. And see if you can talk them into loaning it to you, so anything you've missed, you get caught up. Now, it's on you. If you don't do it, I'm not going to take excuses. When I collect your SSRs, I think on the 14th, not SSRs, those 2, I think they're due on the 14th. But when I collect your journals, I think it's the 14th of May, that Friday, before we review for finals. Before you get your study guides for finals, and then we review on them. If you don't have them then, I'm doing them that weekend and putting them in the computer. So, and if you get it in the next week to me late, it's going to cost you probably 30%. The most you'll be able to get would be like a 70%, which is like the lowest C- you could possibly have. And if it's really, really bad, you're going to end up getting a D on that baby. And your grade is going to fall like a rock. So, word to the wise. I'm saying it to my 8th grade too. So, anyway, I suspect you'll do a nice job with that. You've got time. But you can't say, you didn't tell us, you didn't warn us. It's 6 weeks away. And I'm warning you. To make sure your journal is caught up and make sure you're using it. Every time I say, hey, include this in your journal. Okay, what else you got for us, Mr. C? So you got your journal out. Your homework is to review LS 1 and 2. We have a test on all this coming up, right? Not this week. Next week on Tuesday. A test. What's it going to be on? It's going to be on LS 1 and 2. It's going to be on everything about the minerals that we've done to date. So, and there'll be a matching on which mineral is this. So, on this sheet right here, You better take notes, and you better review this as well. So far we've got rock salt, right? What is it? Halite. It's there on the back, Halite, number 1, halite, down at the bottom, rock salt. Then we did purple quartz. What is it? Amethyst, there it is. So you're going to need to match these. It'll be a matching on these, but it's going to be a lot of points. How many points? 25 maybe? On the matching on the minerals? Well, depending on how many we get done. But I think we might, my goal is to finish all 25 of these, to do another 3 or 4 today. I hope so. Okay, on the test next Tuesday. I'm telling you way ahead. So you've got like 6 days. So I'm going to ask you for the 3 kinds of rocks. SIM, sedimentary, igneous, fire foam rocks that were melted. And then also metamorphic, where they're changed into something else, like shale into slate. The layers of the earth, crust, mantle, outer core, inner core. Mineral characteristics, NiCCS. Naturally occurring, inorganic, unique chemicals, unique crystals that the Lord built into them, and they're solids. Okay? What's a property? A characteristic of a mineral. That's going to be on there. Number of properties like hardness, the Mohs hardness scale. Diamond, the hardest. Luster, how shiny they are. Density, how tight the atoms are packed. So all of that. So now in the meantime, I've got over here, look what I have over here on the side. Hey, can you see it? The little PQ warning there. Here's what it says. Note to me. You just never know when a small pop quiz is going to pop up. You never know. So when I say, well, your homework is to review lesson summary 1 and 2 and the minerals we've covered so far and NICs and all that. And then a pop quiz pops up. You didn't tell us. Yes, I did. And I said review. So when I say review on an evening, better do review. Copy? Okay. So that's it for my reminders. No, it's not. One more. These are due, I think it's about the 14th of May, whatever that Friday is. Some of you have already turned them in. Okay. So that. I'll be doing test number 2, grading test number 2 this week. I hope to have them all in by Saturday, end of the day Saturday, test number 2. And anything you've turned in. I'll be out at school again on Saturday to scoop up any makeup tests and get those in the computer. So let me show you this now. I'm excited about this. This was a national championship basketball game last night between the Baylor Bears and Gonzaga. What are they? They're just Gonzaga. I guess it doesn't say what their mascot is. Oh, there it is. The Gonzaga Bulldogs. Who won? Baylor, 86-70. Was there a reason they won? Well, yeah, usually there's a reason. It's usually data. It's usually the data. And it's the data. Now, I know once in a while there's a game where there's a really bad call and it determines the outcome of the game. And it shouldn't, but it happens. That's just the way it is in an imperfect world. We live in a world where it's not perfect. Sin occurs. Sin is anything that is not perfection. So, anyway, here's the reason Baylor won. Now, during the year, they shot about 42%. Wow, holy cow. 42% on their 3 balls. 42! No, so my prediction was if they light it up with 3s, they could win. Well, how'd they do? They shot 43.5% on 3s. 10 of 23. Well, there it is right there. Well, that's not the whole story, but it's close. Now, if you just heard this, if you just heard this stats are data, right? So if you just heard this data bit, the Gonzaga Bulldogs shot 51% on their field goals. Baylor shot 45%. You'd go, well, I'll bet there's a good chance that Gonzaga won. Well, listen to these other stats, though. Get this. Baylor hit 30 field goals. Gonzaga only hit 25. So Baylor got off a lot more shots. Baylor hit 10 threes. Those stats alone explain the game. But listen to this. There's also another big stat. What is it in basketball? You basketball players. What's the other couple of big stats? TOs, what's that? Turnovers. How many did Baylor have? Baylor had, I think they had 9 TOs. Oh my. Gonzaga had 14 turnovers where they turned the ball over, some kind of violation. Ooh, that was a factor. How about this? What's the other biggie? REBs. What are those? Rebounds. Listen to this. Baylor had 22 defensive rebounds, 16 offensive rebounds, 38 rebounds altogether. And Gonzaga only had 22 rebounds. Oh, well, there you go right there. Those three stats. 3 balls. I guess you could say 4. Percentage of 3 balls. Baylor was outstanding. Rebounds. Baylor was outstanding. And then turnovers. So Baylor won the turnover battle. What was it again? 14-9. So anyway, data. It's data. It explains it, doesn't it? Yep. Then I wanted to show you this. Check this out. This is a ring of fire, and I just want to show you we've got a very active ring of fire right now. You see that red dot off of South America? Is it Brazil? That's an earthquake that happened in the last hour. Other earthquakes have happened in the last day. In the ring of fire. You guys are going to see a video in a little bit on the ring of fire, that explains why earthquakes and volcanoes occur very frequently in the ring around the Pacific Ocean. There's a reason I'm not going to tell you right now. We'll start getting into that next week, the week after that. But I wanted you to see this video today, so I've got to hustle because I'm going to show you this video. So, and then I want to show you this. Do I have this? I think so. I've got to find it though. Is that it? Come on, Mr. C, dial it in. All right, check this out. So I gave you the ring of fire earthquakes. Look at this. You can see the ring of fire right in front of you. Look at all of those volcanoes. There are more active volcanoes right now than there have been in a long, long time. All around the earth. A couple of famous ones that you know about. The reds are active volcanoes right now. The reds. The oranges are warnings they probably are going to erupt. And the yellows is where there's unrest underground, indicating, it's data, that there could be an eruption. By the way, do volcanoes ever kind of like, how do I say it? Do they ever give you a warning before they actually erupt, before there's any evidence of anything coming out of the ground? Oh yeah. Long before you get ash or lava coming out, long before that, or big clouds of poisonous gases, what do you get? Earthquakes. As magma moves underground, it shakes the ground. So you'll get a 2, 3, 4, 5 earthquake on the Richter scale. Small earthquakes underground as the magma is moving up. So volcanoes usually communicate. Hey, I'm going to erupt. Hey, I am going to erupt. So pay attention. Anyway, I wanted you to see that too. Interesting stuff, right? A very active Earth right now. It is moving and shaking. So magma moving, earthquake shaking. So anyway, I thought you might enjoy that. Very cool stuff. Okay, Mr. C, get with the program here. Let's go. Move it, move it, move it. You've got to move it, move it, move it. Here we go. LS2, properties of minerals. Get ready to highlight. All right. In the top box, here's what you're going to highlight. Just the major characteristics there. A mineral is a naturally occurring, all that stuff. So look what I put right beside the top box, NiCCS. So stick NiCCS right to the left of the top box. What is a mineral? NiCCS, that's what a mineral is. Naturally occurring inorganic, unique chemicals, unique crystals, and solids. Okay? And then down below I put coal. No, it's not. Coal is not an official mineral. Why? Because it's not inorganic. It's from plant material, which was alive at one time. So it's organic. Organic means from living things. Okay, middle box. How are minerals identified? So middle box, how are minerals identified? There it is. By their properties. So you're going to highlight properties. Each mineral has characteristic. I'd circle that or highlight it. Characteristic properties. Notice I have down there like hardness. And I've highlighted, did I actually put on there? I should have. There it is. I have underlined the Mohs hardness scale. There it is. Mohs. Diamonds number 10. You've got luster. You talk about luster, check this mineral out right here. It's too bad the camera's not quite delivering on how much luster this has. It is really shiny. Very shiny. So is this quartz crystal. Quite shiny. High luster. Shininess. How light reflects. This one is not. Low luster. It just doesn't reflect light much. It absorbs a lot more light than it reflects. Absorbs it. So if a rock, or any object for that matter, absorbs most of the light that strikes it, absorbs it, it's going to have low luster. It just is. And then over on this side, in the middle box, I've got, see that, atomic packing. Highlight it, atomic packing. Density. Density, how tight the atoms are packed. I guarantee that'll be on the test. All of this is going to be on the test next week. And then down below you've got how minerals form. And I wrote two things up at the top that I want you to put. You see that up at the top of number 3? Minerals form from magma and they cool into crystals. So cooling, I should have put into crystals. Cooling into crystals. Mr. C, do you have a black pen there so you can write it in last minute? Yes, I do. So they cool into crystals. So I'm going to write it right underneath, and it's coming right up, ladies and gentlemen. Cooling into crystals. There it is. Whoop. Cooling into crystals. And then another way minerals form, it's by dissolving in water. See that? Dissolving. So they cool into crystals or they form by dissolving. Those two ways. Number those so we got them. Okay. Here you go. Number 1, cooling into crystals. And number 2, dissolve. You got them? Are you using LS2 to do this? Anything else down below? That's it, those two things. Well, I did want to show you this. This is part of a geode. And down below, and I'm not going to ask this, but it says a geode is a rounded hollow rock that's often lined with mineral crystals. This chunk of amethyst came from a massive geode. Just imagine a huge geode, unbelievably. I mean, the whole geode would have probably cost thousands of dollars if you had the whole thing. I bought just a chunk of it, and I can't remember what I paid at the science shop in Sydney, Australia. These are purple quartz crystals, and we already did it. So anyway, that's LS2. Homework tonight, review LS1 and LS2. Okay, hurry. Hurry, Mr. C, you've got to hurry. I want to do at least 3 and 4. I want to do at least a couple more. All right, let me show you this one. Where is it? It's down here somewhere. There it is. All right, this is number 3. Now I'm going to tell you about this one. I'll show it to you. It's low luster. It's very dense. The atoms are packed really tight. Hey, Mr. C, a hypothesis. Any chance it's got iron in it? It does. Here's the proof. That magnet goes right to that baby. So see the magnet hanging on there? And you look at it and you can see little bits of rust marks. Oh yeah, iron oxide. Yeah. So it's really dense because it's got iron in there, and iron, the atoms are packed tight, high density. So it's magnetic. So what would it be? Really quick, have a look. I'm just going to tell you it's magnetite. Isn't that a good name for it? 8 for mineral. Names for minerals often end in ite, I-T-E. Magnetite, number 3. So find magnetite on the front page, right side. See that? And put a 3 over it, magnetite. And I'm going to do a dramatic reading about magnetite. Here it is. There's a place in ancient Greece called Magnesia. Magnets were first found there, and they were named the magnesian stone. Magnetite is a mineral that contains a great deal of, and you're going to circle this and highlight it, a great deal of, and you know what it is, iron. Great deal of iron. What a shock! It's strongly attracted to magnets. I knew that. You did too. Magnetite. Okay, magnetite. So, you know what? Today, that's all the time I have. We'll do number 4 tomorrow. We'll continue our journey with the mystery minerals. I have a video for you today on the Ring of Fire, where lots of earthquakes and volcanoes are happening today. More volcanoes than, I hope to get this to you tomorrow, more volcanoes than I've heard of in maybe all my life. Never heard of this many occurring. So have a look at this. Check out the Ring of Fire. It's a good little video. And then Mr. Philip will answer any questions for you. So, and remember, you're going to triple R, LS1 and 2, and the 3 minerals we've done so far. Mr. Philip, thank you.